Okay, so in this video I want to discuss how to use a read sensor in conjunction with your microbit and Keytronic all-in-one breakout board. Now, a read sensor itself is basically a sensor that can detect if a magnet is nearby. And it does that by using this piece of glass here and two little pieces of steel coming out either end of it. And what it has is basically two little, I suppose, pieces of steel overlapping each other that come together and touch once a magnet is nearby. So you can see that also on this unit over here. These are two separate units, but both work as read sensors. And how that looks, if you were to zoom way in, basically is two plates which are overlapping like so. And what happens is when the magnet comes nearby, the two of them touch together and completes that circuit. Now, these two separate units work with the microbit. And what they have is basically 3 pins that we need to use. Now, this one actually unit has 4 pins, but we only need 3 of them, and we need to use all 3 on this one. We'll talk about the small unit first of all. So what we have is we have our ground, which is on the far right hand side here, which is our minus. And then the center we have our plus, which is 3.3 volts all the way up to 5 volts. And then we have the signal pin, the far left, which is a digital signal pin. So we'll need to connect that to the microbit and read it using, I suppose, a digital block itself within the microbit code editor. On this unit, it looks a small bit bigger and looks like there's a few additional components on it. But the big difference between it is that it has LEDs connected, which identify when the magnet is, first of all, close to the sensor itself, which we don't have on this unit. And it also has this adjustable bolt up here at the top, which you adjust with a flathead, which changes the sensitivity of the read sensor itself. So it can detect the magnet from further away than usual. Now, on this unit, we have AO, which is a signal pin. We have G, which is our minus, which is our ground. We have plus, which is our 3.3 volts all the way up to 5 volts. And then we have DO, which is our digital signal pin. So we're going to be using the last 3 pins here. So DO, plus, and G. And on this one, we're going to be using all 3 pins. They both connect up the same way to the microbit itself. And they also both work fairly well. I would say the sensor itself sometimes can have a bit of issues of the 2 bars not disconnecting once the magnet comes close by. But that issue happens really on the cheaper units. So the more expensive unit that you buy, the better quality read sensor that you'll have on it. Now, for this example, we're going to use this unit over here because it gives a nice indicator light once the magnet is close by. Now, I'm just going to show you how the wiring works. You're going to need your microbit, your all-in-one breakout board. You're going to need power supplied to your all-in-one breakout board. This board itself can take up to 10.8 volts. So I'm just using a 9-volt battery here to supply power to this unit and supply the 3.3 volts needed to the microbit itself. Then what I'm going to do is I'm going to use my plus and my minus here because I know that I can get 3.3 volts out of the microbit itself. We have our ground, so I can connect the 2 of them up. And then what we can do is we can connect up one of the pins. So I'm going with pin 0 back to DO, which is our digital signal pin itself. What we're going to do then is we're just going to go over to the microbit code editor and we're going to put together a small bit of code just to show you how it works. Okay, so now that we've moved over to our microbit code editor, what we can do is start off by deleting our onStart block and using our forever block because we wanted to read the sensor all the time to display that information. So we'll go for basic. We'll go to show number. Now this show number block shows the number or whatever you've selected or put into this little box here up on the 5x5 matrix on the microbit itself. So that's kind of an easy way for it to display the 0 or the 1 that we're going to get from the digital signal. Then what we're going to want to do is to show that signal, what it's getting back to that pin itself. Now we picked pin 0, so we can actually go to advanced below here and scroll all the way down to pins. And in this, we're going to go for a read digital block, not the read analog, which we usually use for some of the other sensors we've discussed previously, such as the LDR and so on. But what we're going to do this time is go for our digital read pin. We're going to attach it straight in there like so, into the show number block, and we can leave it on pin 0 like so. Now this is very, very basic. That's all we're going to need for this to work with our microbit and read that read sensor itself. Now what you can do is just download that to the microbit. Okay, so now that we have our code uploaded to the microbit itself, we can turn on the power. And what we'll be able to see is we'll either see a 0 or a 1 up on the microbit 5x5 matrix. Now, depending if it's a 0 or 1, that basically means your unit is normally closed or normally open. So basically saying that it's normally touching or separated. Now we're getting a 0 here. So I know if I bring a magnet close to the read sensor itself, that should turn to a 1. So what I'm going to do is I'm just going to get a magnet here, like so. And once I move this close enough to the read sensor, that 0 should change to a 1. Like so, you can see 1. I'll move it away again, change back to the 0. Move close, 1 again, 0, 1, 0, 1, 0, 1, like so. So you can basically use that to detect if there's a magnet nearby. So if you had an object with a magnet on it traveling past, you'll be able to tell if that magnet passed or not. Now the great thing about this unit as well is that it has an LED on it, which also indicates when the magnet is nearby. So you'll see this little LED over here will come on as I get closer, like so.